The deeper we proceed into the unfolding 3I/Atlas case, the more the earliest fragments of data begin to resemble building blocks of a larger, coherent story rather than isolated anomalies. What once appeared to be incomplete snapshots taken in a vacuum now read like early pieces of evidence, breadcrumbs that only make sense when viewed in hindsight. This is especially true of the widely overlooked 45-minute stack frame captured on October 21, 2025, by the astrophotographer known as Astrophoto G, using nothing more than a 14-inch Dobsonian telescope. At the time, the public lacked the language, the analytical framework, and the scientific context required to interpret it. Neither NASA nor ESA had yet released their own high-resolution images or spectroscopic breakdowns. The general consensus was simply that the object was another interstellar curiosity, likely a comet behaving somewhat strangely. But as global agencies and independent observers accumulated data, anomaly metrics, photometric measurements, spectroscopic emission lines, tail length calculations, jet behavior models, and an unprecedented spread of multi-mission imagery, the ability to reinterpret this early October frame with a fresh and forensic perspective became not only possible but necessary. When revisited today, the image produces findings that can be described as nothing short of groundbreaking. The central mass, previously dismissed as an out-of-focus blur or mere pixel smear, reveals a structured geometry far too regular to be the byproduct of natural cometary tumbling. The image shows a sharply outlined nucleus region encircled by a halo composed of multiple colors. A halo that is not random chromatic distortion, but a structured, repeatable ring pattern observable in multiple independent long exposure stacks from different observers around the world. Months later, ESA's Mars Trace Gas Orbiter would capture a remarkably similar crescent shell morphology on October 3rd. Shortly afterward, the European Southern Observatory's Very Large Telescope recorded spectral data, confirming the strange emission profiles consistent with shell-like reflective structures. The fact that an amateur telescope with a moderate aperture captured the same morphological traits weeks before professional instruments officially documented them is significant. It implies that the object was already demonstrating its anomalous geometry long before any government-released imagery confirmed it. One of the most baffling features in the October image is the central void, a dark depression at the object's core. Early on, this was waved aside as a stacking artifact or digital compression effect. Yet subsequent measurements revealed that the void corresponds to a 3.2-kilometer nucleus shadow, an astonishingly consistent value that did not fluctuate despite multiple observations from varying angles and solar positions. This level of structural precision is nearly unheard of in natural comet nuclei, which typically show irregular forms, unpredictable outgassing behavior, and large variations in observed shadow length due to fragmentation and rotation. A void maintaining a consistent value across independent datasets points toward a rigid, stable structure rather than a loosely bound snow and ice composite. The October frame also captured a faint but unmistakable purple arc extending approximately 50,000 kilometers sunward. At first, astronomers assumed it to be an imaging aberration or a misprocessing effect typical of amateur equipment. But when missions weeks later confirmed the existence of a coherent, forward-facing jet emitting purple wavelengths inconsistent with any known solar pressure-driven dust or ion tail, the significance of that early observation became impossible to ignore. Standard comet tail models predict dust flowing away from the sun, not toward it. Jet arcs that face the sun and maintain structural coherence over tens of thousands of kilometers are virtually unknown in natural comets. This behavior became part of what researchers subsequently labeled the anti-tail phenomenon, anomalous tail geometry that defied conventional dynamics, and was later described by Harvard astrophysicist Avi Loeb as the strongest candidate for non-gravitational thrusting we have seen on an interstellar visitor. Perhaps the most controversial revelation tied to the October frame lies in its anomaly metrics. At the time of release, many astrophysicists dismissed the numbers as either speculative or based on faulty calibration. Yet today, they align disturbingly well with high-confidence spectroscopy from professional observatories. Astrophoto G had reported an extraordinarily low dust gas ratio of 0.05 at 4 sigma, far below anything seen in natural comets approaching perihelion, where dust emissions typically spike. Even more striking was the reported Ni Fe ratio of infinity, 0, indicating nickel vapor with no detectable iron. In cosmic chemistry, iron and nickel tend to appear together because they are forged in similar supernova conditions. Pure nickel vapor with absent iron is nearly impossible to produce naturally except in very specific and extraordinarily rare astrophysical environments. The few possible natural origins include highly processed supernova, ejecta, or regions influenced by unique nuclear formation processes, but even these should yield at least trace amounts of iron. Yet the same nickel-dominant signature later appeared in ESO's VLT emission line data, as well as in faint NII and Ni2 lines analyzed by independent spectroscopy groups. The implication is staggering. Either 3I/Atlas is composed of material forged in an environment unlike anything previously observed, or we are witnessing an engineered alloy vapor signature. The October 21st image also reveals geometric symmetry that continues to puzzle experts. Measurements indicate a symmetry value of 1.03 at 5 sigma, nearly perfect by astrophysical standards. Later, when compared with jet morphology captured on August 2nd by the TTT mission, researchers found a staggering 98% geometric overlap. Natural comets rarely exhibit symmetry beyond rough bilateral tendencies due to rotation and outgassing. Achieving near-perfect structural repeatability, especially under the dynamic pressures of solar heating and gravitational interactions, points toward deliberate design or an ultra-stable object whose properties do not align with known natural bodies. If we look closely at the multicolor diffraction halo surrounding the core in the October frame, its significance becomes even more apparent. While initially dismissed as mere chromatic aberration, it now stands out as the first visual hint of a shell-like reflective layer that later became unmistakable in November images from NASA's HiRISE, Gemini North, and numerous amateur deep stack captures. The halo's color bands are stratified, consistent, and radially symmetric, patterns that do not correspond to random scattering by dust, but to layered or structured reflections from a surface with exotic optical properties. The object's body appears to consist of a hardened, reflective material wrapped in asymmetric emission zones, producing brightness spikes that do not track with expected solar heating curves. Natural comets brighten through sublimation. Engineered surfaces brighten through reflection or controlled emission. The October image suggests the latter long before the November releases made this possibility mainstream. As of November 28, 2025, when all available datasets are placed side by side, early amateur observations, professional agency data, spectroscopic readings, tail dynamics, emission patterns, and structural models, the evidence points toward a single conclusion. The object's behavior is not consistent with known cometary or asteroid physics. Its symmetry is too precise, its vapor signature too unnatural, its emission arcs too coherent, and its halo too structured. The early October image now appears not as a curiosity, but as the first forensic exhibit in an investigation that may redefine our understanding of interstellar visitors. Whether the object is an exotic natural relic, a fragmented interstellar shell, a probe, or an artifact of unknown origin operating under principles unfamiliar to human science, remains uncertain. But what is now clear is that the October 21st frame captured something extraordinary long before mainstream institutions had the tools or willingness to acknowledge it. What was once an overlooked amateur photograph now stands as one of the most important early records in the 3I/Atlas investigation, an image whose details grow more significant with every new piece of evidence uncovered.